Hi, I'm Padmaja on my channel Thursday Content. So, in today's video, we will talk about named entity recognitions and how to convert them into an API. We will use FastAPI and how to call those APIs as requests. So, these are the three things we will do. So, first, for the NERs, we would use something Spacy. Then we would also use AllenNLP. This would be useful for the comparison. And the third one we can use Flair. So these are the libraries we will be using for named entities. And the second one we will use FastAPI to write APIs for the above NER code what we would be writing. And in the end we would request from the above API and we would see whether it is working properly or not. So these are the three things we would be doing in this video today. So basically I have created a folder here which talks about NER with API. This is the folder I have created, and there I have one NER main.py file which we will be using Spacy, AllenNLP and Flair libraries to write the NER code. So that is the first thing what we would be doing. So let's get started. All right. So couple of libraries we would be needing for this. So make sure that you are installing all of them. So the first thing we would do is import Spacy. So to install this, you would just have to say pip install Spacy. This is the command we would be using. So I have already installed it. So this is the command to install Spacy library. So I'm just importing it here. It is grayed out because we have not still used it in our code. And the second one, we'll have to install Encore Web Large. So I would say spacy.load Encore Web LG, that is large, and that I'll have to save in NLP. So this has to be installed. So the below is the command to install this Encore Web Large. I have already installed. I'm just giving the command to install. You have to say python -m spacy download Encore Web Large. So this is the command to install it in the for the first time in your command prompt. And then I'm just removing this here. Let it be for your reference. So first one we'll have to write the Spacy code. I'm sorry. We'll have to give a separator for our reference. So the first one I would say for Spacy. So we'll just give a separator like this so we will know where I'll be writing. So the first function I would say in NER Spacy, and the input would be text, that is string, and then I would say NLP text, and let's save this in doc1. And then just we'll have to do a loop, would say for ent, this should be in the next line, for ent entity in doc1 dot ends il ent dot text and ent dot label. So these are the ones we will be printing. So these are the ones we'll be printing. So additionally, these are the items also can be printed, like ent dot start character and ent dot end character. So if you want to, these are the items which also can be printed. So basically if we have a long list, say we are writing my project, and for this one particularly, which is the starting character and which is the ending character, it would give you the numbers. So that can be written, but I'm not writing this. So this the first in Spacy code. So this is done. So later we would call this particular NER Spacy function while writing the API functions. So this is first one. Next, we would write something for AllenNLP. Let's give bitcap AllenNLP. Here again, we'll have to pip install AllenNLP. This is the code to do that. This is the code to install AllenNLP. I have already done it, so I'll just call this function, or I'll just import this. So I would say from AllenNLP dot predictors dot predictor import predictor. This is my first import, first and only import, and then we'll say define NER Allen, and we will include this text, and then we would say predictor equal to predictor from. Where are we giving this from? So basically there is an Elmo model and there is one BERT model. So we will be basically using the Elmo model. So you can Google it, or I will just write it here. This is HTTPS double slash colon double slash, I would say Google APIs.com slash Allen NLP hyphen public hyphen models slash NER hyphen Elmo dot, this is the version 2021 hyphen 02 hyphen 12 dot tar dot gz. So if we have to be sure, okay, this is the one, so let's just copy this one, because if we miss even single character, our model will go for a toss. So let's just say okay. Okay, so this says okay, this is found. So this the link basically I have typed. You can go here, just copy again if that is the right one. Yes, so this is the link I have copied basically. So you can take it from this papers with code link, and then I would have to say entities, sorry, predictor dot predict, not JSON, it's just predict. I would say sentence equal to text, and we'll have to save in some um, variable. We would say entities hyphen Allen, and finally we'll include that in a dictionary, and within a zip we would say entities Allen. I need the tags, and I also need the words. So these are the one, and we would save it in something like entities, and finally we would return these entities. So this is what we are doing. So we are just calling this API, and we are predicting here with that API, and we are just putting it in a dictionary with the zip, and we are returning this entity. So this is the second one which we have written for AllenNLP. Now finally we'll have to write something for Flair. Again for Flair it is the same, pip install Flair. This is the one to install the library. I have already installed, so I'll just remove it. So for Flair we need to write two, one is sentence and one is sequence tagger. So I would say from Flair.data import sentence, and the second one from Flair.models import sequence tagger. Yes, so these are the ones. And let's write the code for this. So we would say define NER underscore Flair, and the input would be the text. Say sequence tagger dot load, and this would be Flair slash NER hyphen English hyphen large. So this is the pre-trained model it would be using, and we would be saving in something called as tagger. And finally, we would say just we'll have to run a loop. Sorry, there is one more line of code I forgot. This is sentence, and we'll have to write text. And this is something, let's save in something called a sentence with a small s. So with a capital S, this is the function, and I'm just saving in sentence. Or if confusion, just you can write sen sen. So here we'll have to write a loop on sentence. So I would say entity for entity in sentence dot get spans, and that would be my NER. So I'll have to return in only one sentence, so I'll just take the end here. Entity for entity in sentence get spans, and let's save something called as entity1. I'm not using a new variable to avoid confusion, so just one, and I would return this particular one. So this is the one we'll be using for NER. So this is the final one. Yep. So tagger also we can predict, or you can just run on sentence. Both would work in the same way. So this is the final code we are done. So we have created three functions. One is for Spacy, one is for AllenNLP, and third one is for Flair. So now after this, we'll have to write FastAPI code to write APIs for these three functions, so that we can deploy in a server within office environments, of course, and we can call it from anywhere in the office. So let me create a new file. I would say file, Python file, and I would say ner.py. So this is my API file, it would be, so ner.py. So basically there has to be two libraries installed. One is pip install. I have already installed, I'm just writing the command here. One is uvcon, this is the server which is used for APIs, and the second one is pip install FastAPI. So the second one being pip install FastAPI. So these are the two libraries we'll have to install. So once it is done, we can write import uvcon, and the second one from FastAPI import FastAPI. And the third one, we'll have to import this NER main.py. But ideally what happens when there is a module, if you see any module, any library given, we install with pip install, within a folder there would be two files, one being the model file or the py file, and the second one being an init file. So sometimes, or most of the times, if we do not have this initialization file, it throws an error. There, it is completely empty file, no content at all, but the file has to be there. So what we have to do right now, in order to import the functions what we have written in NER main.py, we'll have to put it in a folder and add an init.py file without any content, and then we can just import here like any other module. So we can just call this, and we would say new folder we'll have to create. I would say directory maybe, then I would say model. Okay, and now we can close this. We have written, we can save and close this, and NER main, let me move it to model. Okay, so within model we have NER main.py, and then model again, let me create another py file called as init.py. Ideally init before and after there should be two underscores, which I missed, so I just added them. So there I am not writing any content, so I can just close it as it is. And now we can call this NER. I can open it here, so there is no problem as such. We can call it here. From model import NER main. So this is needed to import those functions. And now I would say, since I have already imported everything, I would say app equal to FastAPI, and I just have to write two pointers. One is I'll give the title for the page. I would say NER API. So we are building APIs for the NER, and I would say description equal to NER extracts labels from the text. So this is what my description for the fast API, and let me save this one. Fine. Now, like how we write a Flask app, we would have to just give app.root. So I would say @app.get, and I would give an endpoint NER, and then define my text. That would be text, and basically I'm giving this text as string, so it will not allow any other numeric or any other data type to be taken into consideration. So I'm just specifying in advance that I want a string, and we'll have to write the function here. So I'm writing NER main dot, first is our Spacy, so let's start with Spacy, and we'll have to write text, and let's save. I want this as a list because I have given the yield function at the end, I think. Yes, so here text, and let's save this in output underscore Spacy, and similarly we'll have to write another one that is basically for AllenNLP, so NER Allen, and this would be for output underscore Allen. And the third one, since we have three functions, there is one more for Flair, so we can write the same thing for Flair. So I would say NER Flair. So Flair, and let me save it in something called as output underscore Flair. So I have given three functions, and then last I would say result equal to, I'm just giving a dictionary. My first Spacy output I want to display as Spacy NER from Spacy, you can write. So this is my key, and that output would be output Spacy. So this is something it would be displayed in the web page, nothing much. And then I would say NER from Allen, then I would write output Allen. So this is it, and we can return result. So if you see, I have not considered Flair here in the output. The reason being Flair take extremely long time to process, and particularly if it is GPU, that is better. I do not have GPU in my local, hence I'm not including this in my run code run. I'm just hiding it here from the compiler. I've just commented it out, and the the code is the same. This has to be run basically in GPU based environment, so I have just left it. If it is app.get, well and good, else it could be even app.root, and then you can mention here, this should be fun, forward slash, sorry, forgot. Methods you can write here separately. It's like get or post. You can write here separately, whatever. So instead of that, I have directly written it here as app.get. Anything, both are equal. There is no problem at all. So I have written this result. Yes. So UVCon is basically we need this to run while calling in the command prompt. As in this code, it is not needed, hence it has just grayed out. There is no problem as such. Now we can go to the command prompt and let's copy this file path, and I would say cd copy path. Okay, else we can copy it from here, no worries. I would say cd copied. Okay, now the command what we need to give here is UVCon. I would say UVCon space the file, UVCon, the file name, the API for the API file where we have written all this code, UVCon space NER, and we'll have to just give a colon, and we should say app. So whatever name you give here, it has to come here after app. So the file name is NER basically. So this is exactly what I'm writing. So UVCon space NER. NER is my file name, and then whatever we are writing, app or model or whatever you want to write. So UVCon is our command, NER is our file name, app is something we will be writing next. So NER colon app hyphen hyphen reload. So this is the command with UVCon. So let's start running it. It may just take 10 to 15 seconds. I'll just pause my video here. So yes, so our app basically ran. So this command is important. So it should say application startup is complete. So till here we should get it. So I was just trying to run if it is running properly. Yes, this is giving 200 okay, this is also giving 200 okay. So it is our app is running up and running. So now we can just give a small line or text or sentence and see how it is working. So let's get going. So basically this is the HTTP URL which we should be entering in our web browser. So HTTP 127 localhost with port 8000. So this is the one which we will be entering in our URL. So let's get going. Yeah, this is the one, and this is our NER. So whatever codes we have given, so this is our NER API app name. This is what it says, the description what we had written, NER extracts label from the text, and this is our NER API. It could be if you have many APIs, it just would keep coming next to each other and you will not know. Hence, we'll have to just give an app root. With this, we will be able to identify, okay, this is related to this particular NER. So next, we can, there is something like try it out, basically. Try it out. So this is what we'll have to click. Then only this will be enabled. So if you want to see, I'm not able to enter anything here, so I would say try it out. That is when I'll be able to enter anything. So now I have just got a text. I have got a text here. So that is, I have written something like Queen Elizabeth II had a presidential state dinner for President Barack Obama on 24/5/2011 at Buckingham Palace, London. So that is what I have written. I know it is typical sentence taken from, you know, most of the NERs, but I just wanted to go ahead with a very common sentence and see how it is working, if this FastAPI is working at all or not. So after entering this command, let's say execute. It just takes somewhere around 10 to 15 seconds ideally. With a GPU in the device, it is very quick, which I do not have in my local, hence. So this has run basically. So it is giving us a lot of details about what has it run. So it is talking about NER from Spacy, NER from Spacy, and it is giving all the names and its labels. There's the name, there's the label, there's the name, label, and so on. It is giving all this information. So from this is from Spacy. This is from Spacy. So next, if we scroll down, we will get something from Allen. So if you see, so we are getting something Barack Obama. So this is before person, this is L person. So we have a list of items mentioned in Ellen side. So this is miscellaneous, basically presidential state. It didn't understand what it is. The dinner is also miscellaneous for us, for the you know, Allen, and Buckingham Palace, London. All these three are before location, within location, L location, U location, universal location. So these are the labels given by AllenNLP. I did not run Flair because it takes a very long time to run. It takes at least, it has to download 2.2 GB in runtime, which is very huge if you do not have a GPU. So this GPU is a must. Hence, I did not run it in my local. The commands have been given, the codes have been given. It is the same. So once we have the GPU, we can run and see, you know, in our own laptops, or even with Collab, it works fine. So I was running in my local. So this is it for the fast API. Now we have one more thing left. So that is to call the APIs. So let me just close this. So now, while it is running, we'll have to call the APIs. So let me go to our PyCharm. Let me create another file, another Py file, and this I would name as request or request NLP, request underscore NLP dot py, and this would be my third file. And for this, we'll have to import something called as requests. So this has to be installed with pip install requests, which I have already installed, so I'm just ignoring this. So I'm just importing requests, import requests as R, and I would say input text. Let me give a line gap. Input text is the same presidential state dinner, so I have given this, and then I would say input keys. Input keys is basically only there is one text which we need to give. So since this API is taking the text, we'll have to write it here saying text equal to the sentence which we are giving, that is our input sentence here. So basically that is our input sentence here, input text. So we'll have to write it here. So I would say input text, and then it's only two more lines. I should say r.get, that is request.get, and what is my HTTP? It is HTTP colon double slash 127.0.0.1 with colon 8000, that is my double port, and then I would say NER because that is my endpoint I had given here, NER. So I would say that NER, and again another slash. So this is, there are some warnings which I can ignore. NER, and the parameters, I would say params is input keys. And this, let's save in something called as prediction, though this is typically, this is typically not a model, I would say prediction. And then my results would be prediction.json, because any request of JSON, in the form of JSON, so that would be my JSON. And now I'll print two items. One is, I have two returns. One is output Spacy and one is output Allen. So let me return these two items. So, or it would be NER from Spacy and NER from Allen. So this is the thing what I have to write. So let me write, not this, I'm sorry, not this. This is the variable. We'll have to write this NER from Spacy. So I would say print results, and within quotes I would write this NER Allen, and another one I would say print results NER from Allen. So let me close this. So these are the two items we need to print. So this is the code. So let's try running this from command prompt. So we should be in the same path as before. So it's already loading. We did some changes. If we do some little changes, it'll keep debug equal to true, hence it's giving me some errors too. So let me go to Anaconda. So now here I would have to enter some commands to go for this request to call this particular one. So I would say Python, the name of the file, which is request nlp.py. So this is what I need to write it here. So Python, I would say req nlp.py. So that is it. There is nothing big commands, just we'll have to write this. Now you see we have got exactly the same items what we were getting from our API. So this is this is the one which is giving me um, AllenNLP. I think I have repeated, I'm sorry, let me check. Yes, I have repeated, hence it is giving me the same, so I'll have to change this. This should say NER from Spacy. See, small errors, NER from Spacy. We'll go ahead with the same command again. It would run. Yes, it ran, and see, now you will be seeing two different items. The first one being Spacy's output, and the second one is basically output from AllenNLP. So the pink line, the sky line is basically Allen command, and the pink line is basically from Spacy. This is from Spacy. So we have got two same outputs as the way we have fed into FastAPI. So this is how we basically built what we had written in the beginning. We basically will be writing three different functions for NER. We would be writing the fast APIs, and we would be calling those requests from that API. So we have covered all these three in this particular video. That's it for this video. Thank you so much for watching.